Good morning students, Sairam. Continuing with chapter 7 fractions. In today's session, we will solve the remaining problems of exercise 7.4 and then if time permits, we will discuss a few more concepts regarding fractions. But before we start that, let me remind you that you should always have a pen and notebook in your hands while attending the maths class because it's important that you solve the problems those are being discussed in the lesson. So let's see what is the next problem of exercise 7.4. Problem number 2. Compare the fractions and put an appropriate sign. So we have to compare these two fractions 3 upon 6 and 5 upon 6. We can see the denominators of both these fractions are same. That means we have to compare the numerators and the fraction with the greater numerator will be the greater one. So 5 is greater than 3. So we have the fraction 5 upon 6 greater than 3 upon 6. Next one, 1 upon 7 and 1 upon 4. Here we have the fractions with same numerators. That means we have to compare the denominators and the fraction with lesser denominator will be the greater one. That means the fraction 1 upon 4 is greater than 1 upon 7. See 4 upon 5 and 5 upon 5. The two fractions with same denominator. Then we compare the numerators and the fraction 5 upon 5 will be greater than 4 upon 5. Otherwise also 5 upon 5 will be equal to 1. So 1 is greater than 4 upon 5. Question number 4. Look at the figures and write the greater, lesser or is equal to sign between the given pair of fractions. So looking at the figures, in the first figure, the gap between 0 and 1 is not divided into any part. It is the whole. In the second one, it is divided into two parts. So this represents 1 upon 2. In the third one, the gap between 0 and 1 is divided into three parts. This is 1 upon 3, this is 2 upon 3. Then in the next one, gap between 0 and 1 is divided into 4 equal parts and this represents 1 upon 4, this one 2 upon 4 and this one 3 upon 4. In the next one, gap between 0 and 5 is divided into 5 equal parts and we have 1 upon 5 here, 2 upon 5, 3 upon 5 and 4 upon 5. In the last one, the gap between 0 and 1 is divided into 6 equal parts and we have 1 upon 6, 2 upon 6, 3 upon 6, 4 upon 6 and 5 upon 6. Now let's compare the fractions looking at the figures. So we can see A 1 upon 6 and 1 upon 3. So where is 1 upon 6? This is 1 upon 6 and 1 upon 3 is this one. So by looking at this, you can understand that 1 upon 3 is greater than 1 upon 6. Because the numerators are same, then we compare the denominators and the fraction with lesser denominator is the greater one. Then B 3 upon 4 and 2 upon 6. 3 upon 4, this is 3 upon 4 and 2 upon 6. This is 2 upon 6. So 3 upon 4 is greater than 2 upon 6. Next one, 2 upon 3, 2 upon 4. 2 upon 3 is this one and 2 upon 4 is this one. So 2 upon 3 is greater than 2 upon 4. Next one, 6 upon 6 and 3 upon 3. 6 upon 6 represents 1, 3 upon 3 also represents 1. So they are equal. E 5 upon 6 and 5 upon 5. 5 upon 6 is less than 5 upon 5. 5 upon 5 is 1, isn't it? 5 upon 5 is 1. This is 5 upon 6. This is 5 upon 5 or 1. So 5 upon 6 is lesser than 5 upon 5. So we have given the solutions here. 1 upon 6 is less than 1 upon 3 B 2 upon 4 is greater than 2 upon 6. Then C 2 upon 3 is greater than 2 upon 4. D, they are equal, 6 upon 6, 3 upon 3, both represent 1. So, they are equal. E, 5 upon 5 is greater than 5 upon 6. Next, how quickly can you do this? Fill with appropriate signs. We have to compare the fractions, which is bigger, which is smaller, or whether they are equal. So, here we can see the two fractions 1 upon 2 and 1 upon 5. The numerators are same. We will compare the denominators. So, the fraction with lesser denominator will be the greater one. So, 1 upon 2 is greater than 1 upon 5. Next one, 2 upon 4 and 3 upon 6. When we convert 2 upon 4 into its simplest form, we get 1 upon 2. Similarly, 3 upon 6 when converted into simplest form, we get 1 upon 2. Both are equal. So, 2 upon 4 and 3 upon 6, they are equivalent fractions. They are equal. Next, 3 upon 5 and 2 upon 3. Here we have two fractions with different numerators and denominators. In this case, what do? We find the LCM of the denominators. So, the LCM of 5 and 3 will be 15. So, what do? We convert the denominators of both the fractions so that we get like fractions. So, to convert the denominator 5 of the first fraction 3 upon 5 into 15, we multiply it with 3. So, we have to multiply the numerator also with 3. So, what do we get? We get 9 upon 15. Similarly, when we convert 2 upon 3 into a fraction with 15 denominator, then we get 10 upon 15. We multiply both 2 and 3 by 5. So, we get 10 upon 15. Now, we have 9 and 15, both are like fractions. So, it is easy to compare them. We know that 10 upon 15 is greater. That means the fraction 2 upon 3 is greater than 3 upon 5. Next, 3 upon 4 and 2 upon 8. By looking at 2 upon 8, we can see that it can be converted into simplest form, which is 1 upon 4. Now, we have 3 upon 4 and 1 upon 4, both are like fractions, easy to compare them. Okay. So, which one will be the bigger one? 3 upon 4 will be the greater one. So, 3 upon 4 is greater than 2 upon 8. Next, 3 upon 5 and 6 upon 5, we have the same denominators. So, the fraction 6 upon 5 is greater than 3 upon 5. Next one, 6 upon 10 and 4 upon 5. To have the fractions with same denominator, we can bring 6 upon 10 into its simplest form and we get 3 upon 5, isn't it? So, 3 upon 5 and 4 upon 5 like fractions, easy to compare them. Which one will be the greater one? The greater one is 4 upon 5. So, 4 upon 5 is greater than 6 upon 10. Next, 5 upon 7 and 15 upon 21. Again, to have the same, to make the fractions like fractions, we have to change the denominator. For that, we have to take the LCM of 7 and 21 and it is 21. So, to convert the denominator, here we have to multiply it with 3. 7 3 times is 21. So, we have to multiply the numerator and denominator both by 3. And what do we get? We get 15 upon 21. So, here also we have 15 upon 21. That means both the fractions are equal. They are equivalent. So, 5 upon 7 is equal to 15 upon 21. Question number 6. The following fractions represent just 3 different numbers, separate them into 3 groups of equivalent fractions by changing each one to its simplest form. So, we have the fractions here, we have to change them into simplest forms and compare them and separate them into 3 different groups, because they represent only 3 different fractions. So, let us see how we do that. We have 2 upon 12, 3 upon 15, 8 upon 50 and 16 upon 100. So, for the first one, if you want to convert into simplest form, what do? We take the HCF of 2 and 12 and divide both the numerator and denominator with the HCF. So, the HCF of 2 and 12 will be 2. So, if we divide both 2 and 12 by 2, what do we get? We get 1 upon 6. Similarly, here in B, we get HCF as 3. So, we divide 3 and 15 by 3 and what do we get? We get 1 upon 5. Similarly, the HCF of 8 and 50 will be 2. So, what do we get? We get 4 upon 25. And in the last one, the HCF will be 4. So, again we will get 4 upon 25 as the simplest form of 16 upon 100. So, here we have 1 upon 6. For the first one we have 1 upon 6. For the second one we have 1 upon 5. For third one we have 4 upon 25 and 16 upon 100 is the simplest form of 16 upon 100 is 4 upon 25. Now, let us see the same for the other fractions also. E 10 upon 60 is equal to 1 upon 6 again, because the HCF of 60 and 10 is 10. So, it is 1 upon 6. Then F 15 and 15 upon 75. What will be the simplest form? It will be 1 upon 5, because the HCF of 15 and 75 is 15. Then the HCF of 12 upon 60 is 1 upon 5 again, because the HCF of 12 and 60 is 12. And here the last one, 16 upon 96 can be expressed as 1 upon 6. Its simplest form 1 upon 6, because the HCF of 16 and 96 is 60. So, the simplest form is 1 upon 6. Now, here in this group we have first one 12 upon 75. So, it can be represented as 4 upon 25, because HCF of 12 and 75 is 3. Then again 12 upon 72 can be expressed as 1 upon 6, because 12 and 72, when we find its HCF, it is equal to 12. Next one, 3 upon 18. 3 upon 18, we get 1 upon 6 as its simplest form, because HCF of 3 and 18 is 3. And the last one, 4 upon 25, can be represented as 4 upon 25 only, because their common factor is only 1. Now, we can group these fractions. So, we have 2 upon 12 is equal to 10 upon 60 is equal to 16 upon 96 is equal to 12 upon 72 is equal to 3 upon 18, because each in its simplest form is 1 upon 6. Similarly, the fractions 3 upon 15 is equal to 15 upon 75 is equal to 12 upon 60, because each in its simplest form is 1 upon 5. And the third one, 8 upon 50 and 16 upon 100 is equal to 12 upon 75 is equal to 4 upon 25. All the 4 fractions are equivalent, they are equal, because each represents 4 upon 25 in its simplest form. Now, problem number 7. Find answers to the following. Write and indicate how you solve them. A, is 5 upon 9 equal to 4 upon 5? How do we decide whether they are equal or not? By cross multiplying. Okay, so when we cross multiply 5 and 5, 5 and 5 and 4 and 9, what do we get? When we multiply 5 and 5, we get 25, and we multiply 4 and 9, we get 36. So these two cross products are not equal. That means these two fractions 5 upon 9 and 4 upon 5 are not equal. Next, is 9 upon 16 equal to 5 upon 9? Again, we will decide by cross multiplying. If we multiply 9 and 9, we get 81. And if we multiply 16 and 5, what do we get? We get 80. So they are not equal. That means these two fractions 9 upon 16 and 5 upon 9 are not equal. Next question. Problem 8. Ila reads 25 pages of a book containing 100 pages and Lalita reads 2 upon 5 of the same book. Who reads less? So Ila reads 25 pages out of 100 pages. So what is the fraction? The fraction is 25 upon 100. When we convert this fraction into simplest form by dividing the numerator and the denominator by 25, because 25 is the HCF of 25 and 100. What do we get? We get 1 upon 4. This is the simplest form of 25 upon 100. So Lalita reads 2 upon 5 of the same book and Ila reads 1 upon 4 of the book. Now we can compare 1 upon 4 and 2 upon 5. How can we compare? We have two fractions with different denominators and numerators. So we find the LCM of the two denominators, 4 and 5. Their LCM is 20. So what we do? We convert the fraction 1 upon 4 into a fraction with a denominator 20. For that we multiply both the numerator and the denominator by 5. So what do we get? We get 5 upon 20. Similarly, to convert the fraction 2 upon 5 into a fraction with denominator 20, we multiply the denominator as well as the numerator by 4. So what do we get? We get 8 upon 20. Now we have two fractions, 5 upon 20 and 8 upon 20. So if we have two fractions with same denominators, that means we compare the numerators and 8 is greater than 5. So 1 upon 4 is less than 2 upon 5. That means Ila reads less pages or Lalita reads more. Moving on to the next problem. In a class of 25 students, 20 passed in first class. In another class B of 30 students, 24 passed in first class. In which class was a greater fraction of students getting first class? Let's see how we solve it. So in class A, 20 students out of 25 students passed in first class. So what will be the fraction? The fraction will be 20 upon 25. The fraction of students getting first class. So what is the simplest form of this fraction? 20 upon 25, it is 4 upon 5. Now in class B, 24 students passed in first class out of 30 students. So what will be the fraction of students getting first class? It will be 24 out of 30, that means 24 upon 30. Now we convert it into simplest form by dividing both numerator and denominator by 6, because 6 is their HCF. What do we get? We get 4 upon 5. 4 upon 5 is the simplest form of 24 upon 30. Now we have two fractions, 4 upon 5 and 4 upon 5. So comparing the two fractions, we know that 4 upon 5 is equal to 4 upon 5. So, both classes A and B have same fraction of students who passed in first class. Now, with this problem, we come to the end of exercise 7.4. Now, coming to the next topic, how do we add fractions? Children, you have learned how to add the whole numbers, but how to add fractions, we will learn now. We have two fractions here which have same denominators. That means they are like fractions. So, when we have like fractions, what we do? We just add the numerators and we will keep the denominator as it is. So, when we add these numerators 3 and 1, what do we get? We get 4 and 6 will be the denominator. So, we can understand from this that if we add like fractions, that means the fractions with same denominator, we just have to add the numerator and the denominator will be retained as such. And when we subtract the like fractions, that means the fractions with same denominator, what do we do? Again, we subtract the numerators and the denominator will be retained. Here we have an example, 5 upon 11 and 4 upon 11. They are like fractions. So, what we do? We simply subtract the numerators 5 minus 4. Okay, and the denominator will be kept as it is. So, what do we get? We get 1 upon 11 as the result. So, to subtract fractions with same denominators, that means the like fractions, just subtract the numerator and retain the denominator as it is. Now, coming to exercise 7.5. Problem 1. Write these fractions appropriately as additions or subtractions. So, in the first picture, one part is shaded out of 5. So, it is 1 upon 5 and here we have two parts shaded out of 5, that means it is 2 upon 5. When we add them, what do we get? We get 3 out of 5, isn't it? So, 3 upon 5 we get. Similarly, we have here whole shaded 5 upon 5 and here 3 parts out of 5 are shaded 3 upon 5. When we subtract these two fractions, what do we get? We get 2 upon 5. So, we keep the denominator as it is and we subtract the numerators. So, we get the result as 2 upon 5. Here in the next figure, we have 2 upon 6. This fraction is 2 upon 6. This represents 3 upon 6. When we add them, we simply add the colored balls. How many colored balls are there? They are 5. So, what will be the fraction? It will be 5 upon 6. Children, with this problem, we end this session. We will solve the rest of the problems in our coming sessions. Thank you.